Hi class, Dr. Yeager here. We're going to continue on with our discussion of streams and fluvial processes in chapter 13. We mentioned last time that there are essentially two different categories of fluvial processes. That is how moving water shapes its landform, shapes the land around it, and those are the processes of overland flow as opposed to the processes of stream flow. We'll talk about overland flow first. And overland flow happens as water moves across land before it gets into a stream. And as water does that, it does a couple of different things. One, it breaks apart the soil, right? So you can imagine just a really hard raindrop smashing down from the sky onto the ground. When it does that, it's going to break up the ground a little bit. And as the ground is broken up, the water doesn't just break the ground up, but it also moves some of the weathered particles away. Okay, so we're not only weathering the soil, but we're also transporting the soil away. So this is the first time we're actually going to correctly use the term erosion, because erosion is that third part of the denudation process. Remember, denudation, which we talked about in chapter 11, is the process of weathering, then mass wasting, which is the first movement of weathered material, and then erosion, which is where that weathered material is then carried away, in this case, by a stream. So there are four different types of erosion that happen in overland flow, and in this order they happen: splash erosion, sheet erosion, rill erosion, and then gully excuse me, gully erosion. Splash erosion happens when that first big raindrop hits the ground, and with a dramatic splash like that, you can imagine that one raindrop. And if you can imagine a big spring rainstorm, where the raindrops are just really huge, like big as marbles, if you happen to be trapped out in one of those storms trying to find cover, you've been hit by those raindrops, and they just, they're so big, they hit your skin and they make a sound and they hurt, right? So imagine one of those big marble-sized raindrops hitting a dirt field, and you can envision in your head just dirt just poof, exploding upward, little teeny tiny particles of dirt. Well, that's going to leave a marble-sized indentation in the ground, right? So we're breaking apart the ground, and of course in a rainstorm, it's not just one raindrop that falls. So imagine a million of those raindrops falling and pounding on the ground. And then, of course, as soon as they pound on the ground, they're going to start moving down slope, right? Because that's what water does. It goes downhill. And so those raindrops, as they begin flowing downhill with gravity, they're going to be carrying some of these particles that have been broken off or been weathered off of the ground. That's what we call splash erosion. So now imagine these million raindrops flowing down the slope, right? They very quickly go from being single raindrops to being this layer of water that's moving quickly down the slope. As that layer of water goes down slope, it's going to be weathering the ground that it flows on top of, right? It's going to be weathering that down, picking off other little weakened particles of soil, and it's going to be picking up more and more of these parts of weathered soil that were busted off or weathered off as splash erosion occurred. As that layer of water goes down slope, we call that a sheet erosion, right? And the weathering of the ground underneath the sheet erosion gets greater and greater and greater as this sheet of water moves over the top of it. Maybe as sheet erosion happens, some small little pebbles start to get picked up, right? And these things are bouncing down the hill, and with every bounce, they weather the ground underneath them. Okay, well, it doesn't take too long for this sheet erosion or this sheet of water to be moving downstream to occur before the weathering of the ground is going to end up creating areas that are lower and they're these little teeny tiny, almost streams. They're not streams because they're really, really small. I mean, these things would be, as small as a pencil. Or, they're not very deep and they're not very wide, but because they are down lower, they're sort of mini valleys with mini interfluves on either side. And remember, what does water want to do? It wants to get down as fast as it can. So given the opportunity to stay up on the interfluve or get down in the valley, water is going to get down in the valley. And these little teeny tiny mini valleys are what are called rills. And as our nice slope, which before the rainstorm was nice and flat, as our nice flat slope gets carved up into all these little teeny tiny rills, it's getting weathered and weathered and weathered, and more of that weathered material is getting carried away by these types of erosion. Eventually, these rills will flow into one another, kind of like two first-order streams in a watershed. They'll flow together, and as they do that, the rills become bigger and bigger and bigger and bigger, and eventually these little teeny tiny rills become so big that we have to give them a new name, and we call those gullies. So this is gully erosion, and gullies are well, there's no definitive size for where a rill becomes a gully, but just know rills are real small and gullies are bigger. They're not as big as streams, but they're, a decent sized channel of water where all these rills flow into, and then the gullies eventually flow down into a stream. Okay, so when raindrops fall on a hill, these are the types of overland flow, the type of erosion that happen in this order. Right, the raindrops hit the ground, the sheet goes across the ground, it creates rills. Those rills join together to form gullies. Now, once the water gets into a stream, erosion becomes even more powerful. It becomes more powerful because there's a lot more water in the stream, and more water is going to weather the ground that it flows over more. But more importantly, with more water and more fast-flowing water, the water is more powerful to pick things up. Things not just like little teeny tiny particles of soil, but now a fast-moving river can pick up not just pebbles, but it can pick up medium-sized rocks, or a flooded river can pick up huge rocks. It can pick up cars. It can pick up all kinds of big things. And once those things are flowing in the river, they also become projectiles. So they're not only bouncing along the bottom of the stream and breaking the channel itself up, but when they're bouncing along the banks, they are breaking apart the area, and they're weathering the area around where the stream flows. So a stream flow is much more effective in terms of weathering and erosion than overland flow. And as water flows across the stream, depending on the rocks that make up the stream, if it's a rock like limestone, there's going to be chemical weathering that takes place, and that limestone is going to be weathered away by increased water that flows across there. If we want to think about what the flow within a river looks like, let me figure out a better place to put myself. We can think about how things are transported within a stream. We can think about them in different kinds of load. The bed load, as it's called, is the stuff that's being transported in the stream down near the stream bed. So this would be stuff that either just sort of gets pushed along the bottom, or stuff that may bounce along the bottom, but it never gets too high up in the stream. Dissolved loads are the smallest kind of loads. These are loads that actually break apart down to the chemical, down to the molecular level, and are transported within the stream. And then small loads that are just small enough to be able to float along. These would be those small particles of soil, or the smallest tiny bits of rocks. These, but each of these kinds of loads makes up a can make up a large component of what in totality is the stream, is carrying. There are a couple different kinds of movement that we want to be aware of in terms of how streams move stuff. Things can either be suspended, right? They could just float along, or things can bounce along the bottom, and this movement or this process is called saltation. When you have a medium-sized rock at the bottom of a stream, it's too heavy to just float down the stream, but it's not heavy enough to where it can't bounce along the bottom, and that bouncing could happen as another rock comes along and bounces along behind it and knocks it up in the air, or even just the shape of it, of water pushing it up, and it floats for a minute and then comes back down, sort of bounces down. The largest particles in the stream, the largest rocks, they're too heavy to even bounce down the stream. They just move by what we call traction. They're just pushed along the bottom. So these are going to move really, really slowly. It would take years and years for these rocks that move by traction to move very far. Saltation, rocks that move by saltation are going to move faster than those that move by traction, but they still may take a while to travel any long distance in a stream, whereas dissolved and suspended lodes are going to obviously move much faster. And that stuff that's transported eventually gets deposited, and this is the end of the denudation process until it all starts again. Once something that has been weathered and mass wasted and eroded gets far enough away from where it was weathered off, it'll get deposited someplace. And anything that a stream deposits is called alluvium. And we've all, I don't know, I would imagine most of us at some point have spent some time in a creek or a dried up stream. There are so many of them around here in San Antonio, and almost all of our trails around here are nearby streams. So I would imagine that a lot of us have spent some time in streams. We're probably familiar with what stuff that is deposited by stream looks like. We all know what river rocks look like, right? You can buy river rocks at Home Depot. They're these generally sort of round, flattened, but smooth types of rocks, and they're round and smooth because as they float and bounce down the stream as they're being transported, if you can imagine just a rock just bounce. After it bounces a million times, any sharp little edges on it are all going to have been weathered off, and what you're left with is that nice smooth texture of that river rock, of that alluvium. A lot of times if you dig down in a stream, you'll find that these things are sorted by size, meaning you'll find a layer of very fine alluvium, and then down under that you'll find a layer of larger alluvium and a different size of alluvium under that. They're sorted by different categories of size, and by that we can tell different how the stream had different layers in it, or different levels of water in it, because when there's more water we can carry and then thus deposit larger rocks, and then maybe later the water was lower so it couldn't carry those big rocks anymore. When we talk about streams, we talk about streams that flow all the time, always have water in them. Those are what we call perennial streams. The Mississippi River is a perennial stream. The Ohio River are perennial streams. And then what we call intermittent streams, these are seasonal streams. So if you have a place that has a rainy season, the rivers may have water in them during the rainy season, but then during the dry season, the rivers may not have water in them. The Salt River out in Arizona has water in it during the rainy season, but not during the dry season. And then what we call ephemeral streams. Ephemeral streams are streams, and we have lots of these around here. There are streams that only have water in them right after it rains. They fill up with water right after it rains, and then once the rain stops, the stream dries up again. Those are what we call ephemeral streams. We'll continue on with the next video, and we'll see you then.